I've come to you this morning to share the story of how my team made this transition to DevOps. So I just want to define that quickly because I know people mean a lot of different things. When I say DevOps, what I mean is that you have one team that's responsible for both developing and operating an application or a product. I'm not trying to be opinionated when I say that, that's just what I mean. So my plan today is to tell you a little bit about AppDynamics and what we do, to give you the context for my team. Tell you how operations worked at AppDynamics before we did this DevOps thing, how we came to DevOps and what it looks like now, and then reflect a little bit about kind of how that transition went. But before I get into it, I saw this picture in the keynote this morning, and I was like, shit. People are going to see this thing, and they're not going to be able to think about anything else for the rest of the day because it's so damn funny. So just, why don't you look at it now and get your jollies out. You can laugh. It's fucking funny. And you get all your laughter out now and then put it behind you so we can get serious. I also want to propose a deal with you guys. If the folks in the front in the back come sit at the front, I promise not to be offended if you get up and leave early. So I'm going to give you like 15 seconds to do that. I would appreciate it. I think it's a lot more fun if we're all together. All right. Thank you guys for doing that. So AppDynamics. If I can get my thing to work, was founded in 2008. It is an application intelligence company, which is a fancy way of saying that we instrument your code and then we visualize what's going on inside your application. So we do this in three primary ways. The first thing is we model your application. So you install our instrumentation agent in your software, and it starts doing this distributed tracing thing, where we kind of capture all the network requests that are going between machines, and we build a model of the topology of what your system looks like. And so that's kind of like the first view that you see when you use AppDynamics. Now, once we understand how your software works a little bit, we can actually start to learn what's normal and what's not normal, and then notify you if something goes wrong. So monitoring is really the key use case. Once you have that set up, we send you these alerts that tell you that something is wrong. And if something does go wrong, you can come into AppDynamics and debug and figure out what's going on. Our goal is that you can drill down to the line of code that is actually causing the problem, whether it's going slow or your database queries are failing or whatever it is. We help you debug. So that's what AppDynamics does. We started with Java-based server-side monitoring, and then we expanded to these other server-side technologies like .NET and Node and PHP, et cetera. But what we realized is that if you really want to understand how your application's performance is affecting your users, you have to measure it from where they are. Because your server can actually be blazing fast, but your site is still broken because something is wrong on the front end or in the network between the back end and the front end. And then you can still have pissed off customers. So in 2013, we added this thing called front-end monitoring. We call it end-user monitoring, which is a JavaScript library that you embed inside your HTML page. It measures what's going on, reports it up to our server, and helps you solve your performance problems. In 2014, we added support for iOS and Android mobile apps as well, same idea. And then in 2015, we added something called synthetic monitoring. And the idea there is that instead of waiting for users to come to your website and then finding out that it's broken, you actually proactively test the website by simulating what a user would do on the site on a regular basis from a bunch of test machines. So just to explain my story, I came to AppDynamics in 2012 when we were working on that end-user monitoring piece as an individual contributor, and I helped launch the 1.0 of that product, and then I moved over to this synthetic monitoring thing and started that up, and that's the team that I lead. So let's talk about ops. So AppDynamics sells both SaaS and on-prem version of our offering, which is important for selling to sectors like financial services and healthcare and companies like that. So our SaaS environment at first, it had one component, which was called the controller. And that was a kind of monolithic Java application with a MySQL database. There are several instances of it, and they run on physical servers in a data center in Chicago. And we had this operations team, and their job was everything, basically. Everything from buying servers, setting up the network, actually running the apps, troubleshooting when things went wrong, notifying customers when there are outages, and they were good. They were very optimized for operating this one thing. And it was all well and good until my team came along, and we kind of screwed everything up. So we started to figure out, what's the architecture that we want for this new end-user monitoring piece that we're building. And for a variety of reasons, we realized that the architecture had to be somewhat different. So the first thing is we wanted it to be horizontally scalable. So instead of having these huge Java servers with 64 gigs of heap and stuff like that, we wanted more of a model where you have a load balancer and a bunch of nodes behind it, and if you need more capacity, you just add more nodes. So that was the first difference. The next thing was we said, hey, maybe this cloud thing is getting pretty popular. Maybe we should try running this in EC2 instead of running it on our own bare metal machines. And once we did that, we're hey, spinning up lots of nodes is actually quite easy in EC2. So maybe we should split our application into multiple services. And so that really fit the way that our app worked very well. Of course, microservices was getting popular at that time too, so we were kind of taking that idea. And the first version had 4 different services. And then the last part was we said, why should we operate a MySQL database ourselves? Why don't we let Amazon operate it for us? And so we used DynamoDB and S3 instead of operating some relational database in the cloud. And so we worked on this for about a year. And then towards the end, we said, oh, how do we actually operate? Who's going to operate this thing? Who's going to run it for us? So we kind of took this thing over, and we kind of sidled up to this ops team and said, hey, can you guys just go ahead and run this thing for us? And they were, of course, very accommodating and professional about it. But this new stuff that we were doing was really different than the way the old stuff worked. It's physical to cloud infrastructure, which is very different. Going from a monolith to a distributed system is really different. It introduces a lot of new kinds of failure modes, especially partial failures when one thing gets slow and that kind of screws up everybody else. And we were doing zero downtime upgrades, and so it was just different. And the reality was that most of these ops folks had to focus on the product that was actually already out there, already making us money. They didn't have time to learn this totally different thing. And so what we ended up with was essentially one ops engineer who had some of his time dedicated to helping us out. And he was very good about it, but it wasn't a lot of bandwidth. So I'm going to go through some specifics of how our operations actually looked at this time. And I'm going to be fairly detailed just because I think it's really helpful to hear somebody else's story, in concrete details. So deployment, we had these Ansible scripts that would help us with the deployment, but there were a lot of manual steps involved. It was not like a push-button deployment. And just to decode my little emoji art there, that's a script, an Ansible script, that is also a flaming turd. So in case you didn't get the implication there. The other thing is that the dev team didn't have access to the scripts, to the Ansible scripts. So they didn't actually know how stuff was deployed. And we had many times this would happen where the dev team would add a new required configuration option. And then ops would go to deploy it, and then it would crap out on startup saying you need this option. And ops would be what the hell is this option? So there was this total breakdown of communication in that regard. So deployment was basically a mess. Monitoring. So of course we're at AppDynamics. We have the best monitoring software in the world, but the best monitoring software in the world doesn't help you if you're not actually using it, if you haven't set it up or done anything with it. And we kind of didn't. So what happened was both of these teams kind of thought that the other one was going to manage the monitoring. And so it wasn't really clear who was supposed to set up the health rules for what constitutes the app being healthy or broken. And so things would, actually our monitoring tools would tell us that things were broken, but nobody was there to look at it. And even if they had, our on-call setup wouldn't really have worked. So the ops team had pager duty, and they had this great rotation working for the controller, but none of those folks were trained on how to operate our this new services. And so even if they had woken up, they wouldn't have known what to do. So that wasn't so good either. And then there's this money thing, which we don't usually think about that much at these fast-growing startups, but it turns out that actually money is kind of important. So in theory, ops owned the cost control, but in practice, they were so far downstream of the architectural decisions that went into the costs that there's really not much ops could have done to do anything about costs. So we were just kind of like flying blind in that regard as well. Speaking of architecture, every time we would make some kind of architectural change, the dev team would add a new service, or they would use a new AWS service. So Amazon, as you know, has all these different services, SQS and Kinesis and all these things. And so we would use a new one of those, and that actually has to be operationally onboarded. But what would happen is the dev team would work on it for a few months, and then kind of show up to the ops team with it again, and ops would be like, what is this? Why is it like this? How does it work? Why didn't you use Cassandra? What's the deal? And so that kind of sucked. And that actually would go in the other direction as well. So sometimes devs would be debugging something, perhaps during an outage, and be like, oh, hey, now the service has Nginx in front of it. It didn't have that last week, but now it does. And actually, it turns out Nginx is causing the problem. And it was because ops decided that for some reason we should have Nginx. There was no communication about it, and we actually only found out in the heat of the battle. So not so good. So all this stuff, of course, is pretty clear in hindsight. And you may be thinking wow, you guys are just idiots. How are you possibly running things that way? And it sounds very obvious when I explain it in hindsight, but you have to realize that we actually figured a lot of it out over time. It wasn't just obvious that all these things were broken. And it was like this for about a year or so. But the first problem that we noticed that really was acute and was obvious was the deployment one. So we wanted to solve that problem. And so what we did was we hired Andrew. Now, Andrew is a dedicated, we call him a DevOps engineer. The terminology ops engineer, DevOps engineer, we kind of use them interchangeably. Anyway, we called him that. He reported into the ops team, but his job was to focus exclusively on this new services and rewrite the deployment automation in Chef. And he's not a serial killer, but there's no emoji for a chef or a chef hat, but there is one for a knife, so that was the next best thing I could think of. He's a very nice guy. So he did a really good job. He wrote all this new deployment stuff, and it worked much, much more smoothly. It got a lot faster. It got more reliable. And that was much better. Around that same time, we found that when we were debugging problems, we often required both dev and ops to be involved. Because the problems, especially these kind of microservice problems, these partial failures and things, they weren't obviously just code problems or operational problems. It was a mixture of both. And so we found we were collaborating a lot. And then when we went to actually come up with a solution, again, we kind of had to blend the dev and ops concerns. So for example, if you have two services, service A, which depends on service B, and service B can't keep up with the amount of load that service A is sending, what do? You've got several options, right? One is you could just scale up service B. And that's a purely operational change that you could make. Another one is you could add back pressure so that when service B slows down, then service A actually slows down also so that it doesn't overload service B. And third one is that you might decide that it's actually fine in this case if service B just basically sheds the load, just throws it away and doesn't even answer. Depends on how your application works and what your needs are and all that stuff. All of these options they have both dev and ops kind of implications. And so we found ourselves doing a lot more of that collaboration. So Andrew at this time was now working exclusively with the team. There was another DevOps engineer who was also mostly focused on that new synthetic product. And having this cross-org thing just sort of didn't make sense anymore. It was just needless friction. So of course we did the big reorg. So we've moved the folks who are exclusively working on these products directly under the dev managers for those products. So I want to be really specific about the organizational aspect of it, because I read a lot of DevOps blogs that are like, you should have like good friendly communications and all these things. I actually think that the physically like changing the org so that there's one team who's totally responsible for the thing is an important aspect of this transition. I'm not saying it's necessary and that you can't do it without it, but for us, that was an important part of it. So these product teams now owned the development and operations of these services completely. There was no other team to rely on. And once we kind of were all under one roof, that's when we really started to notice all of those operational problems that I alluded to earlier. And because we were under one roof, we were empowered to actually fix them. And so we started going about fixing stuff. So now I'm going to tell you what we did when we fixed things. And I'm sure you guys have been enjoying my emojis very much, but it's time to get serious, because now I'm going to talk about how things really work now. So no more emojis. I apologize. So the way it works now is there's a Jenkins job. We have a Jenkins server, and there's a job to deploy each different kind of service. And you can just go in there, click that job, specify 2 or 3 parameters, and it will actually do a deployment. So we use Chef to install the software and to configure the individual nodes. And we use Bodo, which is a Python library, to do the orchestration, which is like the spinning up nodes, putting them in load balancers, taking the old ones out, that kind of stuff. Our deployments, we do this blue-green thing. Have you guys heard of this? Raise your hand if you know what this blue-green deployment thing is. Okay, so most of you already know. I'll be very fast about it. It means that you don't upgrade your servers in place. You don't mutate a server to a new version of the software. When you have a new version of the software, you build a new server. And then you build all new servers, and you incrementally roll them into the load balancer and roll the old ones out. And the beautiful thing about this design is that you can roll back trivially. So if you realize that the new code is broken, you just switch the load balancer back to the old services. Of course, at some point, like a few days later or whatever, you kill the old stuff. But it's a really elegant design. The other thing it does is it prevents these snowflake servers from evolving, where it's like there's the same server and it's been there for a year and everyone's afraid to touch it because it's accumulated all kinds of stuff on it. If you're constantly killing your servers, then that just can't happen. Our deployments are done in pairs. So one person pushes the buttons while somebody else watches our monitoring tools to verify that nothing goes wrong. We would like to actually make that verification completely automated, but we're not confident enough in our automated testing. We have customers, so AppDynamics does this monitoring thing. We show you these graphs, right? And we have customers who, if there's 1 minute missing from those graphs, will like file an urgent support ticket and get all upset at us. So it's really important that we don't have any of those data gaps, and that's why we're very cautious about that. And the last thing we do, which I think is pretty cool, is we call it a shadow deployment. I think other people call this a dark launch, where you essentially stand up the new version of the code next to the old version, and then you mirror the traffic from production over to that new version of the code. And then you verify that the new version of the code produces the same results as the old version of the code, except in any cases where you didn't want it to, because there's a new feature or bug fix or whatever. And that gives us more confidence that this build is good. So let's talk about monitoring. So of course, we still use AppDynamics, and we also use CloudWatch quite a bit. But we've really revamped the monitoring. First thing we did is we added a lot of custom metrics. So AppDynamics can figure out a lot about how applications work, but it can't figure out everything. And we found that if we added some manual metrics in our code, we could measure a lot more useful stuff. So we added tons of custom metrics. We use them for debugging, and we also use them to drive a lot of our alerts. So speaking of alerts, we set up a whole bunch of health rules to actually know if the application is healthy or not. And these are things like whether certain endpoints are like much slower than normal or having errors. There are things like, in the case of the synthetic monitoring product, whether those synthetic tests are actually running when they're supposed to run, stuff like that. So we have 2 flavors of alerts, critical and warning. The critical ones we will wake up for. And I'm going to talk a little bit more about that in a second. But what it means is that they really have to measure like business impacting problems, or at least customer-facing problems. So like, this server has high CPU is not in and of itself a customer-facing problem. You could have 10 servers in a cluster, and one of them has high CPU, and the others can pick up the slack no problem, right? So that is not in and of itself a problem. The problem is something like these customer requests are coming in and they're failing in a non-retriable way, which guarantees that a customer is seeing a problem. So that's what we set critical alerts on, because we don't want to wake up for just the random noise that happens in the system. But we do also have warning alerts for some of those infrastructure type problems that can come up, and I'll talk more about those in a second. So if a critical alert does fire, what happens is that a developer is paged. Everyone has PagerDuty installed on their phone. They're all expected to have it set up so that it will wake them up at night if they are asleep. There's a rotation of developers. Now, you may notice that that's just the opposite of what the traditional arrangement. The traditional arrangement is the ops team gets paged, and then they escalate to dev if something goes wrong. And the reason that we flipped it around is because we really wanted to strengthen the feedback loop from production to the development team. So if something is going wrong in production, we don't want the development team to like maybe find out about it if ops can't work around it. We want them to like feel that pressure. We have this kind of philosophy that over time, all applications should trend towards hands-off operation. In other words, we don't want to write software that requires teams of people to operate it. We want to write software that basically runs itself, and there's people there to just make sure that nothing goes wrong. And we think that developers are in the best position to actually make that happen. So if something goes wrong, the number of levers that operators can pull are fairly limited. They can like add more memory or disk to the machine. They can reboot processes and stuff like that. But if the app is fundamentally hard to operate because it leaks memory or because it just uses too much disk or whatever it is, ops team can't fix that. So we think devs have the best leverage, and that's why we kind of wanted to send it to the devs. So if you get paged, what happens is, I kind of skipped this point, but we have this weekly rotation for the on-call. There's a primary person, a secondary person, and then it goes to managers if nobody answers. You have to acknowledge pages within 5 minutes or they'll escalate to the next level. And this is a little bit of an informal kind of cultural thing. We have a little wall of shame in our office for where we record when we get escalated to each other. And you have to buy somebody lunch to get your name erased from the wall of shame. I wouldn't suggest imposing that as like a top-down thing. It's just something that the team has evolved. So once you get paged, you wake up, you start debugging. Once the developer has figured out what's going on and they realize that something actually needs to happen to fix this, there are certain tasks that they can do automatically in Jenkins. Those are the simple things like adding more provision throughput to the DynamoDB tables or rebooting services. But the devs do not have root on all the machines. And that's not a philosophical thing, it's just how we have it set up right now. So if you need to do more, the devs can manually page one of the ops or DevOps folks who also has an on-call rotation. So it's the other way around, right? If dev can't fix it on their own, then they escalate to ops. And the DevOps folks are only paged by humans. They're not hooked up to any of the automated systems at all. And they're actually only paged by the devs who are on their very same team. So you don't get paged by like random other people in the company. The warning alerts, which I mentioned before, those just email the team, and the on-call dev is expected to respond to those during business hours. So if some warnings happen in the middle of the night, we actually won't see them until the next morning when somebody goes through their email. And thus far, that actually hasn't been a problem. So let's talk about cost. So the product teams just own the cost, which is the obvious kind of arrangement. We are held responsible to a unit cost model where basically every license unit of our product that gets used by a customer is supposed to cost us less than a certain amount. That way the company can guarantee its profitability, its profit margin. We review costs in a weekly meeting that has both dev and DevOps folks in it. We use this tool called Cloud Health to visualize. It's a pretty good tool. It kind of slurps in your AWS bill and lets you slice and dice and figure out what's going on. And we have found that there are improvements that we can make for cost that blend dev and ops. So for example, if like the DynamoDB cost is high, we can optimize the query patterns. If we see that EC2 usage is high, or EC2 cost is high, we can buy reserved instances from Amazon, which they give you a cheaper price from. Or maybe we tune our auto-scaling algorithms to actually be a little bit more aggressive in like packing more load on fewer machines. So those kind of changes that we make, they often blend dev and ops concerns. And then there's Beyonce. Beyonce is actually the name of one of our services. And she kind of represents the ultimate DevOps collaboration. So to explain what Beyonce does, I have to go back a little and talk about that synthetic monitoring product, which is what I work on. So remember I said that it tests your website from a bunch of test machines that are deployed around the world. Well, one thing we quickly realized is that if you want to measure website performance, you have to do it in web browsers that people actually use, which means you have to do it in IE, which means you have to run Windows machines, which none of us want to do, but we have to do it for the business, so we make it happen. Also, with Synthetic, we offer 25 different cities in the world that you can test from. And this is actually important for our customers because like, if they're in Luxembourg, they want to be able to test. Or if their customers are in Luxembourg, they want to know how the site performs from Luxembourg, not from Ireland. They want somewhere as close as possible to where their customers are. So that actually requires that we run in multiple cloud providers. So AWS only has, I think, 10 or 11 regions, and so we needed more, so we have multiple cloud providers. And the other thing is that the demand fluctuates a lot, and it's very inelastic, or the capacity of these servers is kind of inelastic. Based on the way the kind of code is architected. So all of this amounts to operating this fleet of Windows machines is actually very complex. There's a lot of stuff that we have to do, and it's kind of a pain in the ass. And so we built this dedicated application called Beyonce, which has its own UI and everything to manage that fleet of servers. And Beyonce is primarily owned by one of the back-end developers, actually, not one of the DevOps folks. But the DevOps folks make a lot of contributions to it, and they're constantly feeding back into how it works. So she really makes managing all these Windows machines as easy as I can really imagine managing a bunch of Windows machines to be. You could say that she slays. So, all right. So did it work? This whole DevOps thing. I think you probably are getting the impression from everything I just said that yes, like all these processes are way better now. And so it's definitely an improvement. But there's just a few other points I want to make. So the teams really, these product teams are able to be very independent. And they can ship as fast as they are able to do with confidence. They don't have to rely on anybody else to get their code out into production. The ownership has become like totally clear. The product team owns the product end to end, like period. We don't have these weird gaps of like, oh, did you guys set up the monitoring, or am I supposed to set up the monitoring, or anything like that anymore. The developers actually contribute to the operations. So devs write some of the chef code, especially if we're making config changes. We'll go and change the chef stuff, the chef cookbooks as well. Devs add a lot of new metrics for monitoring. They set up health rules. They set up alerts. They, of course, are the ones who are primarily on call. And then this last thing is actually something that is really cool that we've started to do. So the thing is that if you know that you're going to have to wake up if something goes wrong, you really don't want things to go wrong. And so we've evolved to a place where even small outages, partial outages, even where just one customer has some small problem, we write a pretty detailed RCA for that, and we make a lot of pretty detailed prevention plans on how to make that not happen in the future. And we find that it's pretty easy for the team to prioritize making those improvements because we know we're going to wake up if we don't make those improvements. So it's kind of creates this feedback loop, or you could think of it actually as like back pressure. In other words, if the dev team is making all these changes to the code and it's making the app harder to automate, then things start breaking. And then devs are actually on the line for that, which means that feature development slows down, which is actually exactly what you want. You don't want devs continuing to pump out more and more changes as the app gets harder and harder to operate. So we think of it as like a back pressure from production to the team, and that has really worked well. There have also been some pretty pleasant surprises. These were things that I didn't anticipate were going to happen, but they did, and they're pretty great. So the first thing is, all of you, I'm sure, have worked on projects where like everything is falling down all the time, and it's really demotivating, and you're like kind of want to cut some corners, and it's a vicious cycle. Right? You go into the neighborhood with the broken windows, and you're not really motivated to keep things good. On my team, my observation has been that hasn't happened. And we've been working on this stuff for about 3 years. So it's not like the first 2 months where everyone's super like jazzed to make everything work great. It's been a while, and still people fix stuff. And I think the reason is that they're empowered too. They don't feel like, oh, there's some other team that's just forcing this thing on me and there's nothing I can do about it. They feel like, okay, this is our thing collectively and we can make it happen. So if you're the DevOps person and you don't know how to make the code change, you can just turn to your neighbor and talk to him or her about it, and vice versa. And I think it works because this being autonomous, having ownership, is intrinsically motivating. I linked it right here to this really good TED Talk. I know it's kind of like uncool to like TED Talks, but I like TED Talks. And I linked to this TED Talk that I think is very good. It's about extrinsic versus intrinsic motivation. In other words, like, do you try and motivate people with perks and salary and good food and stuff like that? Or do you try and motivate them by the psychological factors that make people feel intrinsically motivated and proud of themselves? So I recommend watching that talk if you get my slides. Right. Broken windows. So the other thing is, when you're working on a system that is actually kept pretty tidy, where there's not like this background noise of 1,000 errors per minute that you have to ignore, it preserves this kind of natural curiosity that people have, where they're kind of just poking around and they're like, hey, this thing has an error. Why does it have an error? Right? Like, our stuff doesn't usually have errors, so why is this thing having an error? And sometimes those have actually, that kind of this serendipitous kind of just like poking around has actually caught real problems. There was one case where our system was publishing some data to a system that another team owns, and we found out just through poking around that like 25% of those calls were failing. I'm like, yes, we should have been monitoring that, but we weren't. And of course, your monitoring is never going to be perfect. There's always going to be gaps. And so if you can have this kind of curiosity where people are open-minded and they're just thinking about the system and trying to always make it better, that's a way better place to be than the opposite. So we've also found that, I've been surprised at actually how much the devs get this kind of situational awareness, where they know what's going on in production. They know what version is out there, they know the topology of the deployment, they know the different environments, they know what all the recent problems have been, and they actually think about operability at every stage. So when they're doing feature planning, when they're doing implementation, et cetera, they're actually thinking about how do we make sure that this is monitorable and debuggable and alertable. How am I going to know if this thing goes wrong? So it's really raised that kind of like awareness for the dev team. And actually the inverse is also true, which is that the DevOps team has been involved at every stage of the feature definition. And often they actually make pretty significant contributions to the architecture because they're thinking about how's this going to operate, and they notice a problem. So those have been kind of some of the surprises. I was very worried about on-call. I was very worried about waking people up at night because I care about my people and I don't want them to be pissed off or hate me or quit. And I wasn't sure how people were going to handle it. It's actually been surprisingly fine. People do get woken up sometimes and they're amazingly fine with it. I think they're fine with it because we keep everything in a good, clean enough state where there's no broken windows that it doesn't, it doesn't feel like you're having some horrible system like imposed upon your life. It's more like, okay, we're all in this together maintaining this thing, and it generally works well. Okay, it's screwed up, I better fix it. So a few caveats if you're going to try this yourselves. I don't know where all you guys are at with your thinking about DevOps or doing it. I'd be curious to talk to you, some of you after, about where you are. But definitely a few things that you should know. So your alerts have to be good. If you're generating all types of random alerts and stuff and waking people up for that, devs are going to revolt if you set up this thing the way that we set it up. Because developers are actually pretty whiny compared to ops people, and they don't really want to they can't deal with having to deal with crappy stuff. Just watch them when that mandatory HR training comes around, and you'll see how whiny devs can be. I'm from a dev background, so I'm allowed to say it. But yeah, you have to have good alerts and good debugging tools. And if you don't, you might want to check out AppDynamics, because that's what we do. We do still have a central team that manages some things. So I don't want to make it seem like every team is like an island and they don't have to worry about anyone else. There are these couple things, like there's a master AWS account and the way we communicate outages to customers that actually is managed by a central ops team. And so there's some coordination that has to happen there. And actually figuring out how that was going to work was something that took us some negotiation and time, and it was a little tense for a while. So there was that kind of transition. But the new way is just so much more natural. I'm going to skip these other points. So I just wanted to reflect shortly on why I think DevOps is happening now. Because we've all been operating systems for a long time. It's why is this trend all of a sudden happening? Is it that we just realized that, hey, this is way better than the way we were doing it before? I don't think so. I think it has to do with some changes in the industry. So the traditional thing is the operations has always been a tension of these two different concerns. One is application-specific stuff, as in we have these apps and someone has to run them. And the other is this common infrastructure stuff, especially maintaining physical servers. But there's always been a tension there. But the equilibrium has been that it's worth it to kind of focus on that centralized infrastructure stuff and make sure that we get that right. But of course, some industry changes have totally changed this. So that infrastructure thing doesn't exist anymore. It's all in AWS now. It's just in the mind of Jeff Bezos somewhere, and you just don't have to worry about it. And the other thing is that there used to be this app container concept, and somebody would manage the container, and then you'd have hundreds of developers all contributing to this one process, one Unix process. And that's kind of changed because of microservices. So now we have all these different processes, and the topology of that maps much better to the topology of the teams. And so the kind of natural thing is just say hey, let's let each one of those teams manage their own thing. So I think that's why we've got here. And with that, I will thank you for coming. I have a link here to the product I work on if you're curious. You can tweet me, but I suck at Twitter, so I might commit some terrible Twitter faux pas, or maybe I won't even respond to you because I don't know what I'm doing. So I apologize in advance. And thanks to you guys for coming.